Hi everyone, welcome to another video for Q&A. In this video I'm going to answer this question that I found on ROS Answers, in which the person is having troubles with the TF tree when he's trying to do SLAM with a TurtleBot3. So he's getting an error in robot model. It says that there is no transfer from wheel right link to base link. He said that before installing and starting the SLAM data, it was possible to control the TurtleBot, but once he tries to do the SLAM, the TF problem shows up and he can't do the SLAM. So, and he shares some pictures of what that looks like. As you can see here on the left, all those errors in the robot model says that there's no transfer from base link to map, from base scan to map, etc. So here the same thing, but just the wheel left link and the wheel right link. So I'm going to answer this using ROS-DS. So we're going to go to rds.theconstructsim.com. And this is it, ROS Development Studio. And we're gonna create a new ROS-ject for this. And here you can name it whatever you want. We're gonna name it TF tree with SLAM. Let's say that. That sounds like a good name. And we'll create it. Just hit basic and open ROS-ject. And while it's loading, let me show you our ROS Academy, theconstructsim.com. This is a place where you can learn robotics, and it has more than 50 robotics courses from everything you can imagine, from arm kinematics, machine learning, robot navigation, etc., etc. And this is a great platform if you want to learn ROS. It's either great for either advanced programmers in ROS or beginners. So I suggest you guys check it out so you can start learning. While it's loading, we're gonna have to clone some repositories in order to show you this example using the TurtleBot3. So we're gonna simulate a TurtleBot3 environment in this ROS-ject and show you there. So we're gonna go to the repositories. So if you go to Google and hit TurtleBot3 Robotics GitHub, you're gonna click on the first link, which is the repository from Robotics Git that is provided already. So we're gonna eventually clone this one and two others. Let me show you. The other one is same TurtleBot3, but you're gonna say simulations and GitHub. And it's this one, TurtleBot3 _simulations. And lastly, the same TurtleBot3 messages, GitHub. And it's the first link, this one. So now that we have our ROS-ject open, we can go ahead and clone those repositories. So we're gonna click on Tools over here and open up a new shell. In this shell, you'll see that if you hit ls, you'll have the list of the available workspaces. We're gonna save two of these repositories in the Catkin workspace and one of them in the simulation workspace. So we'll go ahead and start with the simulation, so the Catkin workspace. So we're gonna access that in our SRC folder. And we're gonna go to the first link that I told you, the TurtleBot3, and hit on this button to clone the repository right here. So we go back to our ROS and say git clone and paste the URL that you got. Hit enter and you'll see how it's cloning into our workspace. There we go, and we're gonna do the same with the second link that I told you, the third one, sorry, the messages repository. So we're gonna type git clone and we're gonna go to the TurtleBot3 messages and do the same, copy the URL, go back to your shell and paste that. There we go. And finally, we're gonna hit CD to go back to the home, and we're gonna enter our simulations workspace inside the SRC folder again. And finally, we're just gonna clone this TurtleBot3 simulations repository in there. So the same way, we copy the link, type git clone, and simulations. There we go. So now we're all ready to go and start trying to map with SLAM. So first, what we're going to want to do is we'll just go home and we're going to launch a couple of things. We're going to launch the simulation, and I'm also going to tell you what the difference is going to be if you're actually working with the TurtleBot3. So if we want to launch the simulation, we're going to go ahead and compile our code. So we're going to go into the catkin workspace and we're going to type catkin make, and it's going to start compiling. And we're actually going to do the same with the simulations workspace, just to make sure there's no errors that will pop up. So there we go, it's been built, and we're gonna hit cd ... to go back into our simulations, cd simulations workspace, and do the same. There it is. Now both our workspaces are compiled, so we can launch our simulation. So first, we're going to specify what TurtleBot3 model we're using. So in the same shell, just type export and all caps TurtleBot3 model equals burger. This is the most common one that everyone has. But make sure it's yours. So if yours is waffle pie, just type in waffle pie in there. So now that we did that, we can actually launch our simulation. So we're going to type ROS launch TurtleBot3 gazebo, and our simulation is going to be TurtleBot3 world.launch. And here comes an important difference from if you're using the real TurtleBot 3 or a simulation of it. And if you see here, it's launching the simulation. So it's waiting for services. And in order for us to see it, we're gonna go to this Tools button and hit on Gazebo. And this is it. This is the simulation. We'll make it a little bigger so you can see it. Oh, it's coming up not complete. Sometimes that happens. If that happens, it's supposed to have some walls around it. So we're gonna launch it again because we want that to actually show up. So we're gonna hit Control-C on our shell. If that happens to you, if not, you can just go ahead and skip this part. There you go, and just launch it again. And like I was saying, you're not gonna want to launch a simulation if you're working with the TurtleBot 3. So instead of launching the simulation, the command that you're going to want to use, I'm going to show you in another shell, is going to be this one, which will publish the robot state publishers, which are in charge of the TF tree. That in this case, the person that was asking the question was having some trouble in seeing it. So this launch file is going to be ROS launch TurtleBot3, and it is bring up and TurtleBot3 robot. So that's the one TurtleBot3 robot.launch. So in case you're working with the real TurtleBot, you're gonna want to launch this robot launch, which is in charge of establishing the communication between the USB connections with a node called ROS serial Python, and also everything you need in order for it to work in the real TurtleBot. So here we're going to see if our simulation opened up correctly, and it didn't. Why not? This is odd, but it doesn't matter. We're gonna try again, and launching it like this with the command ROS launch TurtleBot3 gazebo TurtleBot3 _ world.launch. All right. So let's cross our fingers that this is the right simulation. There we go. It's working. So this is what I was trying to get to, because it's just going to be better to map, you know, if the simulation is actually correct. So there we go. Now that we have this, we can go ahead and launch the SLAM node, and I'll show you what it looks like in RViz. And this is probably the part where you got the person that asked the question got the error. It's because the launch file that is used to launch the SLAM node is already publishing a robot state publisher. So if you have one in the background that you were using for other things, it might yell at you and you might run into some problems. So we're gonna launch that and show you where that is. So we're gonna type in a new shell. We're gonna specify the robot model, again export TurtleBot3 3 model equals burger. And then we're going to launch the gmapping node, the SLAM node, and the method is the gmapping, which you can do different methods of mapping, but we're just going to go with the default, usually is gmapping. So we're going to copy this command, and it is this one. So it's ROS launch TurtleBot3 _ slam, TurtleBot3 _ slam.launch, and then the argument slam methods, and it's 2 dots equals gmapping, and this is the method I was telling you about. So we're gonna launch that. And as you can see, it's already doing something. It's already updating and showing counts of measurements it's taking. And to look at this, we're gonna open up RViz. So up here in your tools menu, you're gonna open graphical tools. And this is where RViz is shown in ROS. So we're gonna put it side by side so you can see both things. We're gonna make this a little bigger, like so, and put the simulation on the corner here so you can see how they move in unison. So, and there you go, you can already see that it's already doing the mapping. And I'm gonna show you the TFs so you can see that, in fact, the transforms are working correctly. So we're going to zoom in so I can show you the TurtleBot. So there you can see it, kind of. If the window looks like this, you might want to hit it's yelling at me. You're going to want to resize that window. There you go. And you can see here the TurtleBot3, and if we go to TF, you can click this, and you can see that all of the frames just turned on in the TurtleBot, and you can see that you can turn them off here and check the ones that were failing in the question, which was the left wheel and the right wheel link. And here you can see that they're good to go. Like I said, the problem is that you want to make sure that no other ROS robot state publishers, are being published. And to make sure that, I'm just gonna show you how to do that. In case this happens, if this doesn't happen to you, you can skip this. So here you can type ROS node list, and this shows you everything that you're already, all the nodes that are running. And as you can see, this one is already being published, a robot state publisher, which is in charge of the TFs, remember. So if we type ROS node info and then robot state publisher, you'll see the information from it, and you see who's publishing it. You see what's publishing and what it is subscribed to. So you can see that it is publishing this TFs that I was telling you about. And this robot state publisher gets launched inside the node, the SLAM node. So instead of that SLAM launch we sent, you're gonna see that's where the robot state publisher is being is being ran. So if before the slam node, if before you run the slam node, you run this command ROS node list, and you already see that robot state publisher, you're gonna want to kill it. So when you launch the slam node again, it's gonna be good to go. And to do that, we just type ROS node kill, and then the name of the node, robot state publisher. Again, this is only if before launching the slam node, if you're using the TurtleBot3 that is real, you're getting that node that is running, because that if you launch at one again, that's the same name, you're gonna have issues. So you're gonna hit that and it's gonna kill it, and then you can do all the things that I've shown you and how to start mapping. So now that we're here and the mapping is already begun, you can see that it's incomplete. So if I zoom out here, you can see that it's incomplete. So in order to navigate autonomously and things like that, you're gonna wanna have a full map of your environment. So to do this, we're just gonna move the TurtleBot around. So in here, in a new shell or one that you're not using, you again specify, you always have to specify the TurtleBot3 model. And you're gonna ROS launch the TurtleBot3 TF package. It's called ROS launch TurtleBot3 _ teleop, and then TurtleBot3 _ teleop _ key dot launch. And this is gonna allow us to move our TurtleBot. Oh, it's yelling at me because I do not have the model correctly, which is weird because I just specified it. So we're just going to type it again and launch it. That is weird. See, it's telling me that the following input files do not exist model, which is telling me that it's not getting the model correctly. So I'm going to try and doing it in a new shell. There we go. I don't know what was happening. Sometimes the shells get disconfigured, so a good quick fix is try it in another shell. So here you can move it with your keyboard, and this way we're going to complete the map. So I'm going to put this right next to each other so you can see it. So you're going to click on the shell that you launched the teleop node in, and you're going to just use the keys that are shown right here, W, A, S, D, and X, to just move the TurtleBot around. So you want to like tap it a couple times, and you can see that it's gonna start moving. So we're just gonna make sure that the TurtleBot sees everything. And you can see on the right on RViz how it's starting to complete it, you know? So a good way is just to go to this middle part, and there you go, and rotate it around so it sees everything, and to just go to the places that are not explored yet. So we're gonna go to that far corner over there, and just be careful that you don't crash. Sometimes I get a little too excited. And this is a good idea to do in the TurtleBot as well. You don't want to make it go really fast because you might crash into something. So you can see that it's almost done. Almost close to crashing right there. And we're just gonna look both ways. And there you go. For the example, this is good enough. And you can see that the simulation and the RViz are correct. And they're, now that you're mapped, you've mapped already, so that this is what you're gonna use to navigate. So you're gonna use this map in navigation, so you're gonna wanna save it. So the last step is to save this map. So we're going to open up a new shell, and we're going to use the map server node in order to save it. So here we're going to say, we're going to type in this command. So you can see it, it's ROS run map underscore server map underscore saver /f and then squiggly line /map. This means that it's going to save it in our home folder. So I'll show you. You can just run this. And there you go. You can see that it did its job. It did some things, and it said writing map occupancy data to home user map.pmgm and to home user map.yaml. We're going to use this map.yaml in navigation, but that's for another video. So if you want to actually see where that is, you want to open up the IDE over here in Tools IDE, and there you go. You can see that your map is both in .pgm and .yaml, and now you have your map ready to go. And like I said, that making sure that the robot state publisher is being published only one is kind of important when working with TurtleBot, because otherwise you'll have these errors like this guy had where you couldn't see the frames that it was trying to find the link for the wheels. So if you make sure that that robot state publisher is being published only once, and in the case of the simulation, is being published by the SLAM node, and actually in case of the TurtleBot3, the real robot is being published by that one. So you want to make sure that no other robot state publishers are running in the background. And there you go. I hope you found this video helpful, and I'll see you guys next week for the next video. Bye bye.